Hi everyone, in this video we are going to talk about a statistical tool. It is called two-sample t-test. So the data set we are going to look at is called tree data. So it's tree data and Excel file. And if you look at the original data, you can see we have habitat variable, we have a black birch. So those are the two variables that we are going to work on. And the formulation for the problem is that we want to find, like we have black birch data, which is the density measurements of black birch tree. And we also have habitat data, which describes the location where each tree measurement was taken. So we have habitat number 1 denotes the riparian site plus, and 2 denotes the ridge site plus. So we have habitat as a categorical variable only takes two values, 1 and 2, denoting like different locations. And black birch, we have a numerical variable, which is the measurement of the density. And the question we are interested in knowing is that whether there is a difference in the means for black birch tree density in the two habitats. So we actually want to know, like, what is there a difference or not in the two locations regarding the mean density of the black birch tree? And first of all, you want to set up your null and alternative hypothesis. And the null hypothesis is that there is no difference in the means. And the alternative is that there is a difference. Or you can state it as the mean value of black birch tree density in the riparian site plus is the same as the mean density of black birch tree in the ridge site plus. And the alternative will be the mean for black birch tree in one location is not the same as the mean value in the other location. So you can state it a little bit differently, but we are talking about the same thing. We are checking are there differences or not in the mean values. And when you compare the mean values, the first thing you can think of, especially when you are thinking about a parametric method, you can think about a two-sample t-test, because we have two populations, one from each habitat, and then we are comparing their mean values. So two-sample t-test is the right test for checking on this problem. And you want to import the data set from Excel to RStudio. So I just showed you the Excel data here. So what you can do is to open your RStudio. You want to open your RStudio, but not R, because RStudio can give you the R code that is easier to manage and to check back. So I'm opening my RStudio. So once it is opened, you can see there are 3 windows for now, because I have used it before. So you can see mine is a little messy, but you are going to see a window on the left and 2 windows on the right. But what we are going to do is to click here, the little white paper with the green plus sign. So that is like you can create a new R script. You can either click here, click R script, or you can click file, new file, and then click R script. So which way works better for you, because they are doing the same thing. So I'm going to click here and then R script. And then I'm going to move this window down a little bit. So the bottom window on the left is called console, which will show the output when we run the code on the top. First thing we are going to do is to click file import a data set from Excel because our data is prepared in Excel file, so we are going to find it there. I'm going to click into the document to find the data. So you can see the tree data is here. I can click to open it. And you can see there is a data preview right after you click import the data. So you can see the data preview is here. We have the variables in here. And there is nothing you need to do. You can just click import right now. And you can see a new window is opened. Sorry, I have many other files disturbing us. So I'm going to just close all these documents there. And this is our new R script. There's nothing in there. And this is the new data that we just imported in. And often I would copy the code here and would copy everything in the console and move it to the R script and get rid of the little arrows there because we don't really need them. And this code will help you, like I can just close the tree data. Next time when I open my R code, I can just run the first line, click the right arrow here, and then run the second line. The data is imported, and then run the third line to view the data. So you can see the good thing about clicking File, Import Dataset is that it can help you create the R code that you need. So you just need to copy the code it generated to the R script. So this is the step. You can make a note there. This is a step to import the data set. And the view function, capital V, this is to view the data set, to have a full picture about what variables you have, how many observations you have, and so on. So once you run this, it will open the data table for you. So by now, the data is ready. Remember, we want to do a 2-sample t-test, right? 2-sample t-test. And we can check a few things for the 2-sample t-test. So very often when you have a data set in biology or ecology, you want to visualize that data. You want to draw pictures of the data to have some ideas of it. So for 2-sample t-test, we want to have 2 populations independent with each other. So you don't want to have one sample from one of the populations affect the values from the second sample of the second population. So you want to have independent samples. You want to have normal distribution of the population. So that's the baseline to do the 2-sample t-test. And when you visualize the data, it is a tool to check the assumptions of the 2-sample t-test. So you want to use tools such as histogram, or you can draw box plot. So histogram is to check whether the data is normally distributed or not. And box plot is also good for comparison. You can compare their mean values, at least the median values, and the spreadness of each sample. Also, you can check are they symmetric or not. So you can check different things using different graphic tools. And let's first use histogram. So I believe you may have used the ggplot too, but before I use it, I need to use library function to load that package so that I'm telling RStudio, I'm going to use the functions within ggplot2. So please get it ready. And then I use the ggplot, which is a function that is packaged in ggplot2. So I want to do ggplot data equals tree data. So that's the data setup we want to use. And for the aesthetic information, we want to specify X to be the Y value because we want to draw the histogram. So Y value is the variable there called black birch. So before I draw the graphs, I actually often use names function on the data set so that I can see the variable names and I will not have a typo of their names. So I can run the names function and then I can copy the variable names, not here, the variable names on the top like this. So I can just copy the variable names without making a typo. And so in that way, I'm assigning tree data, the aesthetic information, and then I can add the histogram. GEOM, all of the geometric objects in ggplot is starting with the GEOM. So then you can add histogram, and then you can run that line to see what happens. So there is a histogram looks a little weird. Like black birch is on the y-axis now, which is not the normal the histogram that we often see. So one thing we can do is to change that black birch to the x variable, and still we add the histogram. And you can see there is a notice here. It said you want to pick better values with bandwidth. So let me assign, because our data are very small. So I want to assign bins equals 5. And then bins equals 5 means we have 5 bars for the histogram. And I also want to use facet wrap. So this is a function that can help us draw one histogram for each population sample. Our other variable is named as habitat, so I can just copy that habitat here. I mean, in the coding area. And so this is like I'm using the facet wrap to split the histogram according to their habitat. So if you want to know more information about facet wrap, so you can actually use question mark and with that function, so you can see there are some explanations here. So you can set which variable you are going to use to split the data, as well as how do you arrange your pictures. So in here, let me use number of column equals 1, which means I want 2 histograms, like one on the top, one on the bottom. Let me run this line. So when you run these 3 lines of code, you can either select the 3 lines, or you can just click anywhere on the first line, and then you can run it. So you can see, you can zoom the picture here by clicking zoom, and you can see the histogram for the first and for the second. So you are seeing the histogram for each population, which is each habitat in our data. And this is not very normally distributed. One of the problems I'm thinking is that we only have 18 observations in total, which means we have 9 observations for each habitat. So 9 data points is not good enough to show the hidden distribution of the populations. And then let's check on the box plot. So you can use ggplot again. You can let the data equals tree data. And for the aesthetic information, you can specify X equals so for the box plot, you know you are going to draw something like this. Let me quickly draw a picture. So the box plot often is like this. So you have one category, second category, and then you have a box plot for each category. And the y-axis is showing you like the values. The values here, like the density of black birch. Let me use B and B. So the y value is showing the black birch densities, and the x-axis is showing you the categories. So you are going to have one box plot for each category. And let's draw a graph according to that sense, what we are expecting for the box plot. So the x-axis now should be the habitat, and the y-axis will be the black birch. So the categorical values are on the x-axis and the numerical values are on the y-axis. And then you can use little plus sign, and then you can use GEOM underline box plot. So all the plots, different types of plots are starting with GEOM, geometric objects. And then you can run these lines by clicking anywhere on the first line of the two lines. And you can see this plot looks so weird. So it said continuous X aesthetic. Continuous X aesthetic means the habitat is not being treated as a categorical variable. Remember, for the habitat, we were talking about one is denoting one location and two is denoting another location. They don't have real meanings by using number 1 and 2. And to check on the problem, you can actually type a note here, check on habitat. Is it numerical or categorical? We want it to be a categorical, right? So you can use is dot character or factor. You can check is that factor, and then you can type tree data $ habitat and just run that line and see it is not a factor. So we are guessing the right thing. It is not treated as a factor. It is a numerical variable. Is that numeric? Let's see. Just to confirm what we are thinking is correct. And then we can fix it. Yeah, so the habitat variable is treated as a numerical variable. So the box plot looks so weird. It is not what we are thinking here when I draw the pictures of it. So let's fix it. By fixing it, I mean you can use tree data $ habitat maybe, and then you can change it. There is no meaning to keep the numerical habitat variable. So you can just use the data set $ of that variable and then change it to be a factor. So same thing you're going to put in there, which means you are going to take the habitat from the data set, change it into a factor, a categorical variable, and then put it back into the same habitat variable in the data set. So run that line. And now what you can do is to use table function of the habitat variable within the tree data. You can see you have 9 observations from 1, 9 observations from 2. And if you want, you can still check, is it a factor now? Is it a categorical variable now? True. So, okay. Now we can rerun the box plot R code. So this is a problem when you import data from other resources because you didn't build the data within RStudio directly. So may be confused about the data types for different variables. So you can see there is a problem there. We are able to find what the problem is, and we can fix the problem, and then we can rerun our code without any problems there. So just run that and see, this is the graph we are expecting. And this is the graph I said we should be able to see. So they look very similar. You have habitat 1, 2, black birch, box plot, right? Their median values are close to each other. The spreadness are similar. Look at the width of the box plot, or the spread of the box plot. They are similar. So those are the data visualizations we can do. We just draw the box plot and the histogram. Let me make a note here. Histogram. And a step 2, so that's our step 1 to visualize the data. And a second step people often do, and which is also a very helpful tool, is to use numerical summaries. Numerical summaries are like the mean value, the median, the variance, the standard deviation, and so on. It's a new package called dplyr, and dplyr is mainly for data manipulation. So we are going to load the package called dplyr. And if you have installed tidyverse, you should be able to load dplyr directly. So load that package dplyr, and then we are going to check the mean. Maybe for the summaries, we just check mean and the standard deviation. So for symmetric data, especially for normally distributed data, checking mean and standard deviation is better than checking median and range. So what we are going to do here is to type, just to find the dataset name and copy and paste it, and then use this sign. So I'm using a Mac. It is Shift, Command, and letter M. So I press the 3 keys together. I'm getting a little pipe sign. And then what you can do is to group by. Remember, we have 2 groups. So always keep that in mind and always split the data according to that categorical variable. And after that, add a pipe. And then we are going to type summarize. Summarize is like the numerical summaries we are talking about. So you can call it mean density equals mean of, remember the black birch variable. So I'm actually screwing up in the console to find the names of the data set, the variable names. So I'm going to call it mean underline density equals the mean value, and the standard deviation of the density equals SD is the standard deviation function of black birch. So by now I have typed everything. So I want to have split the data according to habitat, and then do the calculations of their mean and the standard deviation. So I can run these 3 lines. You can see for first habitat, the mean is 1.44, standard deviation is 1.59. And for second habitat, the mean is 1.22 and the standard deviation is 1.48. There is some difference in the mean, but we are not sure if that mean difference is a significant difference or not. So that's why we want to do the 2 sample t-test to see if the differences in the mean value in the sample data is a significant difference or not. So for the two sample t-test, you can just type t.test. And then you can use, remember we have blackbird, which is our numerical variable. And then we have habitat, which is our categorical variable. And then the data is from tree data. I just double click it and then paste it here, copy and paste it here. So you can run this. And in the console, you can see we get a lot of results there. So we are doing two sample t-test, and the data is checking blackbird numerical variable according to habitat. The t-value we are getting is 0.3, and the degree of freedom is here. The p-value for the test is 0.763. So you can see it also re-emphasized the alternative hypothesis for you. So the true difference in means is not equal to 0. Not equal means there is a difference in the mean values. And so now you can actually draw your conclusion. P-value is large comparing with 0.05 by default. P-value is large, which means we cannot reject the null hypothesis. So if the alternative hypothesis is this, the null hypothesis will be the opposite. So this is the alternative given by the test. And you can copy the same thing to get your null hypothesis. So true difference is equal to 0. So because our p-value is large, p-value is greater than 0.05, so we will not reject the null hypothesis, which means we are concluding there is no evidence showing the difference in means is not equal to 0. We have no evidence of that. And that's the whole video for t-test. I hope you enjoy it. Thank you.